We're reaching to the end of an era which data was generated in a naive way, which is basically a function of grabbing data out of the internet or just having simplistic synthetic data generation pipeline. And we are going towards more nuanced and longer horizon synthetic data, which are going to enable these models to go further,
Hello everyone and welcome to a new episode of AI Without Borders. I'm thrilled to have Fernando Neto, a research scientist at Liquid AI, a startup training efficient foundation models that has raised over 300 million. Fernando also previously worked as a research scientist at RCAI, but most importantly for this podcast, Fernando is originally from Brazil. Fernando, welcome. It's great to have you here.
Thank you for the invitation. I'm very glad to be here with you. And hopefully people are going to enjoy by listening to us.
So maybe starting from the beginning, when did you got first exposed to the world of AI?
Well, I was quite lucky to start studying on stochastic systems. And by then I started to play with convolution neural networks by 2016, started to investigate how they should be applied over this kind of stuff, because back then everyone was so pumped with pattern recognition and so on. My research was pretty much like how we could start to think of diffusion process and how probabilities evolve over time. So back then there was an original paper from Google called WaveNets, and that was kind of my introduction to this world of generative AI. So it was a very interesting thing that was related to how can we start to think of producing sounds and music by using convolutional neural networks. It was before transformers, right? So it was the thing. And then I started to do natural language processing when a transformer came out. So I've been doing this for at least the past 10 years.
And so you're now working at Liquid AI. How did you landed your job at Liquid coming from Brazil? And can you share a little bit there about the Dolphin project, what it was and how it was a big career changer?
Yeah, absolutely. I mean, I was very lucky to meet Eric Hartford. He started Dolphin and Samantha, which was kind of one of the first chatbots based on llama models. And we started to engage with him a lot. And then we have the idea to come up with a small entity called Cognitive Computations. So Eric was the main leader there, and I was the second to join. And then we tried to have that as a growing entity. And we started doing some cool stuff regarding open source stuff like the Dolphin datasets, which was pretty much like how can we start to think of uncensored and unbiased models. And by the way, here, uncensored, it's not something related to explicit or not safe to work stuff. The idea was pretty much like diminish the impact of reinforcement learning with human feedbacks and trying to make the models behave in a certain way. That was the original idea. But then we started to expand the research into other things like spectrum, like laser RMT, which were techniques that brought a lot of power for the open source community, which allowed us to focus which part of these huge models we should be training, because there is a huge evidence in terms of there are certain parts of these models that are overtrained, some parts of these models that are undertrained. So by focusing on which parts of the models we should be training, we would be saving a lot of GPU compute, right? And for an open source project like ours, by then it meant a lot because we didn't have access to A100s. We were pretty much very limited, and we have to maximize the grants that were provided to us back then. So, and this was the thing that actually brought first me to RC, both me and Lucas Atkins, because RC is a startup focused on training small language models, right? So saving a lot of GPU compute. And then within IRC, we kind of had a meteoric trajectory. Both me and Lucas Atkins, he became the CTO, I became the head of research. And more recently, I decided to join Liquid. I mean, like, I found a more appealing and more interesting project because of this very specific focus which Liquid has, which is a function of targeting edge and mobile devices.
No, that's a great lesson on the Dolphin project on constraint is a matter of innovation, as they say. And now that you're at Liquid, one of the things that Liquid does is like they train Liquid foundation models. Can you explain what a Liquid foundation model is and how they're different from the models maybe developed by OpenAI or Anthropic or any other research lab?
Well, the main idea of liquid foundation models is how can we access the whole knowledge that we put within the parameters of these models in the most efficient way. So transformers architectures, they have to some extent a decent issue, which is the computational cost grows in a quadratic manner given your input. So if your input is 100, let's say, the computational cost becomes 10,000, right? 100 squared, right? So as your input grows, your computational complexity, your computational cost grows in a quadratic manner, which is like something very challenging when we think of all of this growing demand for a larger context, large process, agentic structures all around. So the thing related to liquid foundation models is how can we minimize the amount of transformer blocks we have in these models, but still trying to preserve uh, the most as we can in terms of the expressivity of these neural networks in such a way that we can find an optimal balance between performance in terms of computational cost and performance in terms of delivering accuracy and reasoning and all of these features that we end up pursuing when we are trying to find the best LLM for our specific use case. So I mean, like, not getting too much into the details. I mean, like, I'm going to leave it open for you so we can get a little bit into the further details. But long story short, the main differential of liquid foundation models is how can we maximize the access to this knowledge, minimizing the computational cost to access all of this knowledge that we kind of crystallize in forms of model weights within these large language models.
So related to Liquid, I was seeing that you recently released like mixture of experts like A, B on device model that at least according to benchmarks perform very well. You just share a little bit of what the company does, but from that specific model, kind of what would innovation allow it to perform that well at that size? Also, how trade-offs did you have to make?
Well, something that we have found out, and it seems like this is one of the core things of our internal mantra. If I were to say something like we try to follow religiously, is data, right? So I feel like the most common mistakes which most of these startups end up doing is not dominating the full cycle of producing, crafting your own data. So data is the very first thing that differentiates what we do, and startups which are trying to focus on the very same thing are trying to do, right? So and data can be a function of two main factors: data quality and scale. So what we have observed so far is that if we throw a lot of data, but very high quality data, and being very high quality data is also something tricky because it's not just a function of distilling a lot of data of frontier models. It's not that. It's a function of preserving entropy, which, if I were to translate into layman terms, is a function of diversity of your data, and also the length and, how can I say, the quality of the reasoning traces if we are solving complex problems, if we are solving simple problems, if we are solving hard problems. So when we take into consideration all of these different dimensions when we are thinking about data. I feel like if I were to specify one of the major secret sauces of being successful is that, and I feel like most of the previous attempts on building small MOEs was a function of data quality and the scale of this data, right? So we have trained this model to a large amount of tokens with a very high quality data, so, and all the rest, I feel like, okay, like there is some small internal breakthroughs in terms of the architectural details, which is a function of the liquid foundational models. But I feel like data corresponds to at least 40, 50% of our success. But this is my very personal perspective. Maybe there are other researchers that might not fully agree with this statement that I've been doing so far.
No, but I think in general people would agree that data is king. And what role, given the focus that Liquid AI has on device, what role on device models, in your opinion, will play in the future?
Well, the very first thing that I feel like people are starting to pay more attention is the role of tools, right? So, what we have been seeing, especially over the past 2 weeks, there's a lot of interesting evidence coming out of recent studies about the capabilities of these small models with test time compute and reinforcement learning to become effective planners, right? So when we should be using specific tools, right? So being able to plan your actions and being able to use the correct tools, you end up open new venues for these models, which were not possible by then. So, for example, like instead of doing test time compute to solve complex math questions, I could actually use a tool, a Python interpreter, and use SymPy, which is a symbolic manipulation package within Python to solve that operation using symbolic manipulation, pretty much like in line with what Gary Marcus has been advocating. So this kind of merging between neural approach and symbolic approach. So there are tasks that are pretty much straightforward for a symbolic manipulation algorithm, structure package, are way more efficient than transformers in order to perform this kind of task. So, I mean, like the very first thing is decoupling planning from actually using transformers as a jack of all trades, right? So if you're doing math, you can use Python as a tool. If you're thinking of performing some coding agentic task, then you break up into a very specific workflow. This is what I called guardrail test time compute, right? So instead of having for a GPT model, a Sonnet 4.5, doing just test time compute and trying to do all on its own, you basically have some sort of sequence of actions of these models. And actually, this is something that Sonnet does amazingly well, right? So if you think of how it tries to solve a task, it breaks down into smaller tasks and then goes back and forth over the tool. So access the GitHub as an MCP tool and then go back and forth and then test the code. And eventually it starts to generate JavaScript on the fly and do some other kind of tests. So this is the this is something that I feel like we are going to become able to compress and put inside these small models. Of course, like we are not expecting for someone building a website or a full application from their mobile device. But I feel like, for example, there are tasks that are still relevant that people are going to be able to build from their edge device. So, for example, like having an agentic task to go back and forth over a SQL database, or performing something very similar as the deep research day-to-day kind of tasks. I feel like they are going to excel on device by this kind of decoupling between planning and tool use. And then over tool use, you can have the reinforcement learning fine-tuned version of your modules that are very capable of interacting with a very specific tool. So if I were to summarize into few words in terms of what I see as the future of all of these models on mobile, on edge, is turning them into agents. Like, let's have something better than Alexa, you know, to perform our day-to-day tasks.
And are there any, as you think about on device, are there any big misconceptions you think people have as it relates to on device models?
Yeah, pretty much like people lack the knowledge of what these small models are really capable of. And especially something that I feel like it's a misconception that people usually have is test and compute is a form of overcompensate the lack of depth that these models actually have. And by the way, this is something very interesting, which is one of the things that I've done back then when I was at Cognitive Computations before joining IRC. And then there was this huge explosion in terms of test time compute. In 2023, we've made a very interesting exercise, which was we had back then the Phi 2 model, right? Very old now. And we've made an exercise of trying to loop the information flow over the layers, which was a very basic model. So it was a very naive way of trying to extend the test time compute in order to produce a single token. We started to witness that the model became insanely creative. So from those exercises, we started to make what the open source community started to call Frankenmerge. So for example, like we had llama models with 70 billion parameters, and they had approximately, if I'm not wrong, 80 layers. And we started to stretch these models up to 120 billion models. And they started to become very creative and becoming able to nail more complex questions. So the thing is, when you stretch and you do more computations over these large language models, they become more powerful, but they consume more processing and they end up consuming more memory. So when we end up doing test time compute over a very small language model, we end up coming with an alternative way of having something that is capable of doing or accomplish a very narrow specific task, but still fits on your mobile device. So, for example, like I feel like this is the main misconception that people end up having regarding this model. So, yes, it's possible having, for example, like something performant like deep research or one on device, going back and forth using your internet connection and reason over different calls over Serper API or Google search or whatever search engine that you're using within your pipeline.
And related to Frankenmerge and model merging, so during your time at RC, you create a new model merging technique called Fusion. Can you first share what model merging is for people who are not as familiar? And secondly, describe what was the innovation or differentiated approach that you took with this new Fusion model merging technique?
Absolutely. Yeah, yeah. So first, what is model merging? Model merging is something very hacky, which works, right? Which is just a function of how can we reuse previous knowledge or do some sort of transfer learning between models which share the same architecture without having to retrain this model, right? There is no back propagation. There are no gradients involved in this kind of operation. So long story short, knowledge is stored over these models in form of parameters, right? And basically knowledge is a function of the magnitude of the values of these parameters and how do they interrelate to each other. Basically, we can do some form of weighted average between different models to see how can and end up coming up with some sort of blend between these two models or any models depending on the technique. And basically what we are trying to achieve when we were trying to test different merging techniques is how can I preserve the capabilities of model A and model B and obtain a model C that has both models capabilities, right? So long story short is how can I blend two models without having to retrain a third model on top of the outputs from model A or model B, right? So this is what merging is all about. And is fusion. Fusion is a special technique that we came up, which is something a little bit more sophisticated and serves for a very specific purpose, which is like if I have model A and model B, and B was a fine tune from A, how can we bring the capabilities of B back to A, but try to recover something that A might have lost when I obtained B? Because very often when we do fine tuning over over A to obtain B, we observe what we call something called a catastrophic forgetting. So eventually, to put a new piece of information within this model, I might end up losing something else during this process, right? And this is a function of how the gradients behave during training. So that's the main reason why it's called the stochastic gradient descent. So stochastic means they are subjected to some form of noise. So when we are passing gradients trying to teach this model something new, there is a part of these gradients which are function of signal, which is the piece of information that we are putting inside these models. And there is a part of these gradients which is a function of the noise, which is the natural uncertainty, which is a function of the seeds, of the stochastic fluctuations. That's why it's called floating point representation, because there is some sort of uncertainty. So there is a lot of variables regarding stochastic gradients that are also small perturbations that we inherently have during this process to make the gradient escape from local minimum. So it's a function of this noise that we end up losing something when we are trying to bring new information to this model. And what fusion does? Fusion, it's basically a new mathematical method which tries to identify saliencies over the model weights in order to detect what is above a certain threshold, which very likely carries out meaningful information that you brought from your training, and what was just a function of the noise, which is inherent to stochastic gradient descent. So when we remove that noise, we end up having a very powerful combination of the new information that you've brought, but still preserving the original capabilities that the model had. So this is very, very important for model fine tuning.
No, that's very innovative. And jumping a little bit, in our previous chat that we had, we were speaking about the bitter lesson, and you had an interesting view. Can you share it?
Yes. Well, basically, I feel like something that everyone is not paying too much attention regarding the bitter lesson is data is scaling compute, is scaling everything. It seems kind of the right way of doing deep learning, but there is a huge importance of making all of this stuff compressed and meaningful and having some sort of strong grounding by human beings, or at least in some sense of as a result of agentic workflows which were conceived by human beings, you know? This comes to the encounter of what we have been witnessing in terms of agentic workflows, in terms of how we are scaling reinforcement learning, which is a function of we are hitting the limit of, that comes back to the original point that I was saying about the data quality, which is, if we remember from the beginning of our talk here, which was a function of diversity, right? So it's very hard to keep diversity or entropy in more technical terms in a decent level. And on the other hand, so if you keep scaling data recklessly, you are going to basically have a lot of repeated data, and the quality of your data will start to diminish. Right. And if not, we might be witnessing the beginning of a lot of junky data being produced by all of these LLMs. So, and this goes to the encounter of the need of agentic, of the need of people curating these agents outcomes, the need of having structure environments to produce synthetic data, which is from a larger perspective, it's everything intertwined with this huge demand for agents, this huge demand for reinforcement learning, for this future that we are starting to build. And I feel like this can be pretty much like explosive for the next 2 or 3 years. So we are coming out from simplistic multi-turn data generation. I would say like we're reaching to the end of an era which data was generated in a naive way, right? Which is basically a function of grabbing data out of the internet or just having simplistic synthetic data generation pipeline, which imitated human user interactions with an LLM, right? And we are going towards more nuanced, more grounded, and longer horizon synthetic data, which are going to enable these models to go further. So, I mean, like, I feel like the main challenge for what we have been witnessing in terms of the bitter lesson is how can we continue eventually to scale up all of this data, but with way different strategies. Otherwise, our entropy, our diversity, our data quality will diminish severely.
And as the model make that progress, and for example, a longer horizon type of agentic task, especially as it relates to the agent framework portion, do you think as we keep going forward, a lot of what's being solved today by the agent frameworks gets solved by the next generation of models?
Well, the agentic workflows as they are, if we strictly focus on those simplistic frameworks which keep track of different system prompts and contexts which are used on very specific parts, I feel like they are going to get deprecated. I feel like the models are going to be agentic. Actually, Claude 4.5, for example, I'd say like it's the clearest use case of agentic model. I mean, like it's natively an agentic model. So I feel like everything will follow that path with very narrow, laser focused approaches. So, for example, this is something that we've also been investigating at Liquid. So how can we have very small agentic models on edge performing meaningful stuff for people doing deep research on your cell phone, like instead of going through several different tabs, which is something like we end up doing on our cell phone, right? You can just do that by a deep research locally on device. And this is the kind of thing that if we go back like 6 months ago, we use it to do that using LangChain, LangGraph. I don't know if you remember, for example, like there were several open source implementations of what should look like a deep research agent on NA10, on LangGraph. So as your model starts to learn and it starts to become able to do planning, then it becomes meaningless having an external workflow. We usually try to build a workflow when we are not confident that the model is able to follow a multi-step reasoning process on its own. But as the model becomes able to do that, I feel like this workflow orchestration is going to become less meaningful, but still like, okay, like there will be always room for those, because if we start to abstract these more atomic parts of your process, there will be always room for a further abstraction on a higher level, making all of these things connected. But I feel like, again, if this is doable by using a step function in the cloud or with simplistic Python code, it becomes trickier to justify using this kind of framework. I feel like they're just going to become like a complicated part of your software stack. But there is room for context engineering, for memory management. These are the things as of now these models don't do by themselves.
And one of the other topics that we have mentioned a couple times during the podcast is fine tuning. So fine tuning gained a lot of momentum in 2023, but a lot of that momentum seems to have faded away. What's your view on the future of fine tuning? Especially many of the companies I speak with kind of are moving away from fine tuning, at least today, given how fast the foundational model players, I'll include even Liquid AI, there are moving. And when do you like? What's your take on the future of fine tuning? Like, do you think it will have like a comeback moment or not?
I'd say like you're completely right on your assertion. Fine tuning, at least for the masses, is just fading away. So I feel like there was a huge hype during 2023 and the middle of 2024 regarding fine tune. But why? The main reason why it's because all of these models are becoming way, way efficient in instruction following and in context learning capabilities, right? So as you become more powerful in terms of instruction following and in context learning capabilities, naturally you're going to need way less fine tuning, right? Because if the model is able to do right away as a function of your prompt, then there is no need for fine tune, right? And so I feel like this raises the first point regarding your assertion, which is correct. So also we have been witnessing the birth of the SPY, which is a very strong framework, and then as these models become more capable in terms of instruction following context learning, then in conjunction with the SPY, then we have changed it a lot, which is like, let's stop with this thing of handcrafting everything. We are going towards a programmatic way of solving our needs of having our model accomplishing exactly the thing that we are willing to have. So the SPY brings up this programmatic view. And even more recently, what we have been seeing is something called GEPA. It's a function of genetic evolutionary algorithms for prompt optimization built on top of the SPY, which is even very competitive against reinforcement learning fine tuning, with the downside of having to rely on an external teacher model to help on this genetic evolutionary algorithm to pursue the best prompt. Because as these models become more capable, we are just basically bringing the whole world data inside of this model. So instead of having anything that eventually might be out of distribution, which is where we observe these lops, we are turning everything inside the distribution, inside the training distribution. So this has been much of a function of the instruction following capabilities that we have been witnessing. And as these models become more capable, and if you have access to a stronger teacher, it's just pretty much like a function of how can we transform this prompt here to obtain this specific output here with this kind of a very powerful assistance to achieve our goals. So when we do all of that, and obtain our specific goal, the way these models end up working as a function of their in-context learning capabilities are very similar in the way of the density of the information that we have with the way the gradients behave when we are doing reinforcement learning fine-tuning. When you're doing reinforcement learning fine-tuning, basically you're trying to teach the model how to maximize its internal capability of retrieving something that it has seen during its training phase, its pre-training phase, and highlight those capabilities, and then make the model behave in an optimal way to achieve that task. This very lightweight tune that we end up doing over the model, because doing the reinforcement learning, we are basically not teaching something new to the model. There is nothing new that the model hasn't seen so far. And that's a function of the rewards. So instead of providing the full trajectory for the model to inject learning and knowledge within this model, we usually just rely on signals that we call rewards. So for example, it's a function of if I have called the right tool, if I have done correctly the math operation, or if I have retrieved the right information, right? So instead of having the full trajectory, all the logics, all the tokens, etc., we just rely on this weaker soft form of signal, right? So in one hand, this enables us to scale a lot of data and make the model learn on top of its internal experience when playing within these environments. But on the other hand, very hardly the model is going to be able to learn something that it hasn't seen. So this is pretty much like the similarity of what we witness in terms of in context learning and a very powerful prompt optimization by applying the SPY and what could be achieved by reinforcement learning, right? So having that said, and trying to be shorter here, the main thing that we observe is fine tuning, giving all of that became meaningless, at least for the masses. Fine tuning, of course, it's a part of the post training stack. So for example, this is my bread and butter liquid. This was my bread and butter RC. So it's going to be needed by the frontier labs. I don't feel like that's something going to be needed by the masses. 89% of your use cases are going to be solved by the SPI or going to be solved by just simple prompt engineering because these models are very smart, or going to be solved by its inner capabilities of having this agentic stuff built in the models, you know? So I feel like that explains a lot of what you have said.
No, that was an amazing breakdown there. And speaking of trends, the current trend I've seen in the market is around building RL, reinforcement learning environments, which I know it's your current area of focus. Two parts. One, if you could define what an RL environment is, and two, what are the biggest challenges in creating reliable RL environments today?
Well, I feel like that's a big hype there. So first, what is an RL environment? An RL environment is basically like a gym. You don't get stronger by just sitting down in front of your TV, having a lot of Cheetos and drinking Coke all the day. You must get into a gym, exercise yourself, and provide feedback for our muscles in order to become stronger. Intelligence for these models ends up behaving pretty much like in a similar way. So we must provide the stimuli for these models, right? In order to make them identify which parts of its internal structure they should highlight, they should make them stronger in terms of features to become able to accomplish a simple task. So an environment usually is a function of what are the observables and what are your actions and what are the outcomes of what you observe and of a function of your actions and the agent that performs those actions and observations and are rewarded accordingly to those signals that basically are the stimuli that we are trying to bring to the model, right? I mean, like in a very simplistic terms, this is what an environment, for example, like having an environment which runs a Python interpreter. It's basically what we need to make these models eventually succeed in Python code crafting and achieving a meaningful result. So instead of just throwing tokens for these models and trying to teach these models by just simple imitation of how to craft a program, we actually try to stimulate the model how to craft on its own based on trial and error instead of having synthetic data right away. And then we reinforce the correct behavior as a function of these rewards that we observe over the environment. So for example, like I provide a prompt for the model, like do a Python code that calculates the integral of the Gaussian distribution. And then the model must get into this environment, produce a Python code, come up with the result, and then we verify if the result actually matches the ground truth. So instead of providing the model the whole tokens as we use it to do in the traditional supervised fine tuning, we let the model do its own mistakes, find its most successful trajectories, and reward positively these successful trajectories to reinforce this positive behavior.
And what do you say is the biggest challenge there? And connecting that with the follow-up question that I had, are you bullish or bearish on the startups that are emerging, offering a little bit RL environments as a service?
Well, I feel like I'm a bit bearish, on them. For example, like I feel like there are very challenging parts for having something meaningful in terms of reinforcement learning, especially something that we call reward shaping, right? So this is something that is basically a function of the researcher experience. Like, for example, how can I tilt the rewards in order to punish a little bit if the model does this kind of behavior, or what I'm looking like to reinforce in terms of a very specific behaviors that I feel like they are going to sound positive. I mean, like on math problems, for example, it's pretty much straightforward if you're not using any tool to reward this model. So, like, I'm going to provide a reward equal to 1 if the answer is correct and 0 if the answer is incorrect, right? So, this is the most basic reward shaping that I could have. However, if I try to introduce tool use in order to reach that answer, then it becomes tricky. For example, sometimes the model might use the tool. Sometimes the model might not use the tool, because one thing that is also quite challenging over these models is that eventually they become overconfident in wrong stuff. So why I'm trying to teach these models to use tools? Because I'm willing to get rid of this overconfidence that they might have on wrong answers, and instead just focus on building Python code that actually do the computation for me, right? I'm not willing to have the model slopping like 2 + 1 = 4, right? So in order to reinforce that, I must shape my reward in such a way that if the model, for example, doesn't use Python, I must discount the reward, even though like the answer is correct. I must provide a negative feedback on that. But how strong should be that negative feedback if the answer was correct? Because there is the challenge, which is like, I must also have a way of trying to not make these models forget the correct things that they already know. Eventually they might slop. However, they do know the answer. So there is a lot of balance over that, which as a function of the tasks become harder and complex. Reward shaping is something very, very critical. So I mean, like, okay, people might be providing infrastructure for reinforcement learning fine tune. But again, like having infrastructure as a service, it seems like, I mean, you're just removing just a small part of the equation, which I would say it's not the most complex part of the equation, if you're willing to have a successful reinforcement learning fine-tune project. So that's why I'm a bit bearish. I mean, again, there are wins over there. Yes, of course. Like if I could spend way less time dealing with infrastructure problems that I face on my day to day, because all of this open source stack is not much straightforward. Having VLLM set up, having VRL set up, etc., etc., etc. It's not trivial. But on the other hand, there is also something that people should be mindful, which is there are several different reinforcement learning environments. So keeping track all of these and having a so fast evolving field, which is basically what we are witnessing right now. I mean, like it's very hard to make a hard decision about which reinforcement learning framework we are going to choose. Usually, for example, for some type of problem, we are going to choose VRL. Sometimes we might choose something else. Like it's very hard to have a jack of all trades in terms of reinforcement learning. So I feel like quite challenging as well, thinking of all of these options we have, having frameworks being adapted and arising every single day. So how these companies are going to keep track of all of these things to provide something meaningful, because the hardest question is how we can make things work very quickly in a meaningful way to solve a very specific task. And having, for example, VLLM working with VRL, and eventually that works for a very specific branch, So, I mean, like, this is one of the things that consumes most of my time. And I can't see as of now these things being solved out of the box by any platform, besides
Yeah.
this technical question that I was providing as well, like reward shaping, etc., etc.
No, it's gonna be interesting to have the same conversation about the topic and see how it ended in 2 years. But jumping gears, the other area I wanted to touch is so you've now worked at two startups that are pushing the frontier in terms of research, but that they also intend to have a very application focus at the same time. What have you learned in those two experiences about the relationship between research teams and teams like go to market or product? And do you think research should drive the progress or should customer needs take the lead? And especially, are there some things on the positive side that you've seen working especially well in that relationship?
Well, that's a great question. I feel like actually that explains a lot about the success of certain startups and failure of other startups. Because first, researchers are always going to have the natural behavior of getting to rabbit holes. So curiosity is basically what drives a researcher. It's passion for solving problems, right? And it's very hard for a researcher kill its darlings. So the very first thing it was a hard lesson for me. And I feel like this was one of the most precious takeaways: when to kill your darlings, right? Because things might be feasible, but you might not have the resources or you might not have the time. And you must have a fit with what your DTM team is bringing in terms of necessity, in terms of what they have perceiving, realizing as a function of potential customers, prospects, suspects have for their inner use cases, for internal use cases. So I feel like finding this balance is critical. And I feel like it's one of the most precious things that a good manager must have. So fortunately, for example, at Liquid, I've been managed by Maxime Lebon. So his fame comes before the person. Right? And besides his technical knowledge, he's also someone who is consistently pursuing, participating events, listening. It's not just a function of a technical knowledge. It's a function of perceiving what people are willing to have, but also having the ability of distill the signal from the noise, differentiate the signal from the noise. Because on the other hand, if a researcher has this natural behavior of curiosity and pursuing and getting to rabbit holes, GTM people has the natural behavior. Pardon me, folks, my GTM colleagues, but GTM folks usually freak out very quickly. Like, holy shit, like our competitor is doing this other thing. We are getting late. So it's a constant fear of missing out stuff. And over all of this hype that we have been witnessing, it's tempting, but it's a poison, because if you don't focus and if you don't learn on what you should be focusing, and you end up doing only tactical moves instead of doing strategical moves. So, and I feel like this is one of the greatest challenges that companies and especially startups have been challenging, because they end up pivoting a lot and not delivering an MVP because it's a constant fear of missing out. And then also, on the other hand, it's hard to switch gears from researchers like, oh, stop researching this, and now you're going to research this other thing here that I'm providing for you as a mission. I feel like there is a challenge of building some sort of synchrony and a trusting relationship between GTM and the research side of the company, you know, in such a way that they should have some sort of faith that what is being researched is actually going to bring value for these customers. And there is also the trade-off that everyone should be aware of, which is, if it was easy, your prospect, your customer would do on its own. They wouldn't ask you to do. So it takes time to deliver stuff as well. So I feel like there is a kind of a complicated relationship, but finding the right balance is the key for the success of any AI company. And I feel like, for example, we are finding a quite nice balance related to that at Liquid. Like there is a constant meeting. There are weekly technical meetings which we try to contextualize for the other parts of the company what is going on from a technical perspective. The GTM team also contextualize for us what have been the demands, how easily has been to pitch new ideas for the customers, because then we also have those signals for eventually killing our darlings, which is very painful for us as researchers, but it's needed.
That last one I think was golden in terms of tactical advice founders and both researchers can take from the podcast. But jumping to the last section, I would love to ask you the quick fire round. It's basically 3 quick questions, and you give me your quick, short answers. What is one concrete initiative you think we could do in Latin America that would lead to see more breakthroughs in AI research coming from the region?
GPU. We don't have access to GPS. Yeah, exactly. We don't have access to GPU at all. If we had access, we have brilliant people here. But I mean, like, I had to start my career by renting GPUs by myself. I had no support. So if we had access to GPUs, we would see way more Latin Americans doing AI research.
Hopefully we can change that. What's the trend in AI that excites you the most coming into 2026? Ideally one that you think it's a bit overlooked.
I feel like AI on the edge. I feel like there is a lot of investment being done on AI infrastructure. And I feel like people are not paying too much attention on the capabilities of AI on the edge. There is a lot of demand, a lot of use cases, which we must not rely on a centralized infrastructure, healthcare, for example, how to reach distant places all over the world, so.
And to close by, are you long or short NVIDIA and a short why?
I feel like I would still bullish. I'd buy. I mean, like weekly bullish, I'd buy because I feel like there is a huge demand for compute. We are going to extend test time compute further and further and further, especially within this world of agents. Something that must be very clear for everyone. I would be buying NVIDIA. I would be buying, for example, this one I would be actually way more bullish, AMD. If I would rephrase the question, would you be buying AMD? Definitely I would be. I feel like these guys are closing the gap, From a wide range perspective, there is a lot of demand for test time compute, inference, maybe not for training, but definitely for inference.
No, Fernando, it's been great having you here. Really enjoyed the conversation.
Thank you. Thank you for having me here.